This is Jack Jackson. We're going to look quickly today at StatCrunch, introduce that a little bit. So I'm in the site, the My Math Lab or My Stat Lab site for our textbook, and if you look down here on the left side, you'll see a menu item for StatCrunch. If you click on that, it will take you to this page here, and you can just work with StatCrunch with several things that are online, or we can use some data sets from our textbook. So let me go to data sets from the textbook, and we have different data sets available in each chapter. These are like from some of the homework problems or examples and things. So I'm just going to kind of go down here and maybe see what I can do, see what this data set looks like. Okay, we might look at that. I think I want to start with something more like, yeah, this will work. Okay, so here we have some data on number of siblings, and notice it's listed in this table here, and it just imported that from a data set that was already in the textbook. Now of course we could just type in our own data here as well if we'd rather use that. But let me show you a couple of things that you can do with this data. For one thing, we can compute some numerical statistics. So if we go down, click Stat, and go down to Summary Stats for the column, we can select the column that we want our data from. If there are more columns of data, it would give us options there. And it sort of defaults to a certain list of things here. But if you've looked, there are a few more over here. I'm actually going to select everything. I'll click on the bottom one, Shift, and click on the top one. And now they all show up over here. Okay, and I'm going to compute all those built-in statistics. And so we see that it's for column siblings. The mode is 1. The n, which is the sample size, is 40, so there are 40 pieces of data. The mean is 1.3. The variance is 0.93 repeated. Square root of that is the standard deviation there. Standard error, median, range, minimum, maximum, first and third quartiles, the interquartile range. The sum is right there. Unadjusted variance, unadjusted standard deviation, skewness, and kurtosis. So I think, let me look at this. I'd have to double check this, but I think that, okay, so variance. So I think this is the unadjusted is if this is a population, and if this is a sample, these are the sample values over here. You can double check that by comparing them to values from your calculator. Skewness and kurtosis. So most of these things we will talk about, not all of them, but most of these things we'll be talking about in the first unit where we talk about descriptive statistics. So there's some numerical descriptive statistics that we can compute. Now we can also compute some graphical statistics. Okay, so we can go to graph. One thing we can do is do a dot plot. Dot plot of siblings and compute. And here we can see the dot plot. So each dot represents one item. Well, let me go back to that and see if that's where we have it set up. Point size, let's do 1. And we can put, labels. Number of siblings, and then frequency. Okay, and maybe compute that. Oops. Of course, you have to select that. So each dot here represents one data value. So we get a 1 here, we put a dot. 3 here, we put a dot over here, and so forth. And when we get the dots, then stack up. So we see that there are more 1s than anything else. So that's the mode. which was showed up here in our table here. And we can see the frequency of each one like that. Okay, so there we have that. Another thing that we can do, let's see, is a bar plot from the data. Let's see how that works. So this is basically the same kind of information here. Now, a bar plot here is going to give you a bar for each value, but if there were some missing values, it would not leave a space for it. So this is probably a bar plot is most best used for categorical data. But here, if we take a histogram, that's going to be a little better. It's going to be about the same thing here. But if there were any missing bars, there'd be a space for them, and so you get a full number line going along the bottom. So there we have that. If you notice, it's pretty much the same information that we have in the dot plot. Sort of a different way of looking at it. Okay, I'll get rid of those. What else can we do? We could do a pie chart. And it gives the value, the frequency, and then the relative frequency as a percentage. Okay, so we could do that. We can do a stem and leaf plot. Stem and leaf is not going to be real helpful for this data. I'll do that again. I'll do that for some other one later on. We can do a box plot. And so we can see the box plot there. So you can make various different kinds of graphs very easily. We can also do this. We can do a frequency table for this. This is kind of nice for this particular one. And so here we see the things here. So the number of siblings 0, 1, 2, 3, and 4. It counted them up, and so we have the frequency, which is the count. So there are 8 times there are no siblings. 17 times that the people have one sibling. So 0 would be an only child. This would be 2 children in the family when you have one sibling. 2 siblings, 3 and 4, and we see a frequency here. And then, of course, if you add those up, that's the total amount, which we have done here somewhere in 40. And so if you do 8 over 40, that is the frequency, which in decimal form is 0.2. And some of these here could possibly be rounded off sometimes, but we have the relative frequencies here, so it produces a table like that. So we can produce some nice little tables really very easily with this software. Okay, so that's a quick introduction to this. Let me do another type of data set to see what we can do with it. For example, okay, well here's some kind, I'm not even sure what this is for, but this is looks like some categorical data. So here a bar plot might be appropriate. And we can put them in essentially alphabetical order is what we have here, or we can put them where the counts are ascending or descending. If you put the counts descending, this gives you a Pareto graph, at least the bar plot part of a Pareto graph. Okay, let's see what other kinds of data sets. I'm just kind of randomly clicking around here, so I'm not sure what I'm going to get. Let's see, I think there's one in here somewhere that's a frequency table. Yeah, here's one with a frequency table. It looks like this may be at some particular college. We have ranks of the professors there. We have the full professors, which is the highest rank. Associate professor is next. Assistant professor. Instructor is the lowest rank. And then we have some others here. Maybe there's some sort of possibly temporary faculty or something like that. So, but what we have here is a frequency table. So what we could do is, again, we could do a bar plot, for example, and go from with summary. So here we have the summary. And notice the categories are in rank and the counts are in frequency. Excuse me. And let's see if we can make that a little bigger. And so now we have our nice little bar plot. Not necessarily in the best order, because there is an order to this. So there is this is somewhat of an ordinal data, so there is an order to this. And we don't have them in the right order here. Actually, if we put professor at move that bar to the front, we'd have them in a sort of a decreasing order of rank. So we can work with frequency tables as well. Okay, well, let's leave it there for a quick introduction to StatCrunch.